Hello, this is Mrs. Mendy, and today we're going to start talking a little bit about chemistry. And here's where we're going to start. We're going to start with elements, compounds, and molecules, and other ways of classifying matter. So, when I say matter, this is what I mean. This is the scientific definition of matter. Matter is anything that has mass and takes up space. Anything that has mass and takes up space. So it could be ice cream, it could be wind, even though you don't feel like air has mass, but it does, and it takes up space. You can tell that it takes up space when it pushes against you, like the wind blowing this person's hair. And this cat has mass and takes up space. So, what isn't matter? I mean, you can think about everything as being matter, but not everything is. So, take a second and think of one thing that you know that is not matter. And then I'm going to go on. Okay, so let's talk about some things that aren't matter. So here are some things that students have thought of in previous years. So sound is not matter. Sound is a pattern of vibration moving through matter. It itself is not matter. Excuse me. Empty space is not matter. There's no matter in it. Light is not matter. Light is a change in electromagnetic field. Gravity is not matter. Matter has gravity, but it is not gravity. And also computer programs, and there are all kinds of other things. They take up space on a hard drive, but the drive is there anyway, so it doesn't really take up space. It's just like a pattern on a hard drive. Um, thoughts, people have also said. That's not matter. It's a pattern in matter. So, and thoughts would be like sort of electrical impulses moving in certain ways. Okay, so those things are not matter. An atom is the basic particle of matter. And most people have heard of atoms before, but they may not have a set idea about it. But I know that you guys went over this in 7th grade, so I'm going to go fairly fast through this, okay? So this is the smallest amount of an element, is an atom. An element is a substance, some kind of stuff, that is made out of only one kind of atom, so only one type. So like all of these structures here are made of only one kind of atom, carbon atoms. But that doesn't mean they're exactly the same, but they're all elemental carbon. So graphite, like in your pencil, is made in these flat sheets of carbon where they're connected side to side only and very little top to bottom. Diamond is carbon, but you can see it's connected together in a different way. It's very much connected up together. So the only difference between pencil lead, which isn't really lead, it's carbon, and diamond is how they're connected together. It's the exact same kind of atom. Here's some other forms of this that are less commonly known. Lonsdaleite, which I don't even know what that is for, but these ones down here, carbon nanotubes, those are being used a lot nowadays because they're really strong but really light and have lots of interesting properties. Fullerene, which is exactly the shape of soccer ball because it's made up of hexagons and pentagons and little balls. And graphene, which is kind of, you can see why it's related to graphite because it's in a single sheet like that. But they're doing all kinds of cool stuff with this, but it's all carbon. It's all elemental carbon. So think about this. This is checking your understanding. So water can be zapped with electricity and broken into hydrogen and oxygen. So if that's true, is water an element? Think, 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 think. If it can be broken into two different things, is water an element? Well, no, it's not. It's not. because an element is made of only one kind of atom. Okay, that's what you just learned. So if something gets broken into two other kinds of atoms, it wasn't an element to begin with. Okay, a chemical bond is a link between atoms that connects them together. So this is glucose here, and they're showing in this kind of model of molecules, they show the link as between this chemical bond as like a stick, and they call these ball and stick diagrams. So here's the bond between here, and then these round things are the atoms. Okay, it's a model. They don't exactly look like this. They look kind of like this, not this stick part anyway. But it's easier to see the pattern that way. A molecule is two or more atoms held together by chemical bonds. So two or more atoms, they can be the same kind of atom, like here in this hydrogen molecule, and this is a different way of showing what molecules look like. This is more realistic, where it looks kind of like two balls smushed together. But it's hard to see the structure. So this ball and stick diagram, it's easier to see the structure, but it's less realistic. It looks more like this. Okay, this is a caffeine molecule, and the different colors show different types of atoms. So like white is usually hydrogen, black is usually carbon because of coal is black. Red is usually oxygen, and blue is usually nitrogen. You don't need to know that. I'm just telling you, just so that you know that there's a meaning to the colors. A substance is a single kind of matter. So it's a bunch of one kind of molecule. Okay, so substance is all the same stuff on the molecule level. So like carbon dioxide is a substance, hydrogen, lithium, water, oxygen, they're all one kind of molecule or atom. Because like lithium, it's not in a molecule. It's just atoms of the same kind altogether. So a substance can change its state, like solid, liquid, gas, or plasma, and still stay the same substance. So sometimes we have different words for it. Sometimes we don't. But like for water, we have different words for water. When it's frozen, we call it ice. But it's the same stuff. It's the same molecule. It's just the relationship between the molecules changes. So that's a substance. So is a table a substance? Look at the table that is nearest you. People are usually near tables when they're at school. And think about that. Is a table a substance? Okay, well, no, because the table is made out of different things. You can see it's got wooden parts and it's got metal parts, and the ones at school, those blacktop tables, that black top is a different substance. Um, your table at home may be made of different stuff. Okay, so no, because it's made of more than one kind of molecule. Okay, a compound is a molecule that is made of two or more elements. So remember, a molecule is something made out of two or more atoms, but a compound is a molecule and it's two or more elements. So the atoms are different from each other. Okay, so are these compounds? Let's look and see. Looking at this oxygen molecule, it's two oxygens bonded together. Is this a compound? Yes or no? No, it's not a compound because they're both the same. It's a molecule, but it's not a compound. How about this water here? Water is one oxygen bonded to two hydrogens. So is a water molecule a compound? No. Yes. No, it is. No, I messed up. Sorry about that. Yes, it is. It is a compound because it's made out of two different kinds of atoms. Okay, hydrogen molecule, compound or not? Not, because they're two the same. You got to have two different elements for it to be compound. Okay, DNA molecule. This is just a small section of a DNA molecule. Yes, this is a compound because look at all these different kinds. There's black ones. And usually in things like this, it'll show a different color, or sometimes in simple ones, they'll have a letter showing like what kind the symbol of that atom is. Okay, all different kinds of atoms shown by color. There's phosphorus and oxygen and carbon and nitrogen and hydrogen, all those things. A chemical formula way of writing what a molecule is. So instead of drawing the little picture, we do this shorthand with letters that stand for each kind of atom. So a water molecule is H2O, which means it's got two hydrogens. This 2 goes with the letter before it. So 2 hydrogens and 1 oxygen. We don't put a 1 there just because we don't need to. There's only one of them. Okay? Just like kind of in math, you don't write 1x. You just write x. Okay, different substances have different properties, and they can be a physical property, which is a property you can see without the molecules changing. It's sort of like a thing that is true of the substance. Okay, and among the many, many physical properties, these are just some examples. There's color is a physical property. Melting point, here's some melting iron. That's a physical property. So you melt the iron, but the iron doesn't change. I mean, it changes state, but it doesn't change from being iron. Flexibility, how flexible something is. This is actually a flexible LED, which I think is cool. It's just invented these a little while ago. And the boiling point, so here's some corn boiling, and that water has a certain boiling point, and that's a physical property of it. You don't have to break the water molecule, to boil it and find out what the boiling point is. Okay, a chemical property is different than a physical property. Chemical property describes a substance's ability to change into other substances. Okay, so that's weird. It doesn't stay the same. So examples of that are, does it rust or corrode? So like this steel that is in this car is rusting, so it's changing. That's a chemical change, and it's changing from steel into rust. And rust is a completely different thing. It's where it bonds with oxygen and comes apart. So like gold does not corrode, not very easily. So here's some gold from ancient Egypt, thousands of years old, and it looks fine. It's not corroded at all. This is less than 100 years old, this car, and it's already corroded away. This is thousands of years. Does it burn? That's a chemical property. So like this oil is burning in this oil lamp, this paper is burning, but the clay that's here is not burning. So it doesn't burn. That's a chemical property of it, is it does not burn easily. How can you tell if something is a chemical property? So you can tell if it changes into something else. If it can change back easily, then it's not a chemical property. Okay, so in just practicing this a little bit, to think about atoms and elements and molecules and compounds and what all those things mean. Let's practice a little bit of that. So looking at this molecule, this is an amino acid. That's like a building block of protein that's in your body. So looking at the atoms, so how many individual atoms are there? Let's count. Each little atom is going to be one of these little balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 atoms, if I counted that right. But not that many elements. So we can see, let's like here in this model, it's the different colors that show the different elements. Okay, so right now there's white, 1, red, 2, black, 3, and blue, 4. So there are 4 different elements in this. Okay, so see the difference? It's the kind of atom that it is. Let's do the same with this one. How many? Well, let's do the easy part first. How many elements? Let's see. There's white, 1, blue, 2, black 3, red 4. So there are 4 different elements in this. Theobromine is the flavor in chocolate that makes something taste or smell chocolatey. And then atoms, it's a whole bunch. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 atoms, but only 4 elements. Okay, lots of bonds too. Nicotine, let's do this one again. So how many elements? Let's do that first. Well, there's white, black, and blue, so that's 3. 3 different elements, 3 different kinds. Okay, how many atoms? Well, that's a big counting. I'm going to start, let's see, I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, I think, if I didn't mess that up. If I were writing on paper, I would probably write the number right next to it so I wouldn't get confused. Octane, a big part of gasoline. So how many atoms, how many elements? Let's look and see. So how many elements? First, the easy one. Well, there's 2. There's these grayish black ones and these little white ones. Okay, so it's 2 kinds, 2 elements. How many atoms? Well, you could even count the atoms of the different kinds, but let's just count all of them together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 26 atoms, if I didn't mess up, 2 elements. Okay, looking at this to see if you remember which is an element and which are compounds. Okay, well, let's see. Let's look for which are the elements first. And remember, elements are when there's only one kind of atom. So that's these ones. These ones only have one kind of atom. And then the compounds are molecules where it's bonded to different kinds of atoms. Okay, not all the same kind of atom. And that's these guys. Okay? Which are molecules? Which ones of these are molecules? Remember, molecules are things that are bonded together. Atoms bonded together, at least 2, can be more than 2. Okay? So, whoops. So this one, and I didn't circle these, this one's a molecule. This one's a molecule. This one's a molecule. These guys are loose atoms. Okay? Now, after this, only ICP classes go after this. So if you're in 8th grade science, just stop right here. But I'm going to go on for ICP. Okay, a mixture is 2 or more substances mixed together but not chemically bonded. So at the molecular level, it looks all mixed up. So like tea, it looks like one thing. It's not just one thing. It's got water molecules, it's got different kinds of tea molecules, but they're mixed together. They're not bonded. You could separate them. Same with milk. There's water in milk and fat and protein, some vitamins, different stuff in there mixed together. Sand. You can kind of see the little different types of rock that make up the sand because it's little different colors. Grain is a mixture because it's got different stuff in there. Like even within each grain, each little wheat grain, there's fat and there's protein and there's water. There's all kinds of stuff mixed in there. Chocolate is a mixture of stuff. They're not chemically bonded together. There's fat, there's flour, there's, well, I guess not in chocolate, that's in brownies. This pasta salad is a mixture. You can see that it's got more than one kind of thing in there. A homogeneous mixture is a mixture that looks uniform, that it is uniform. It's mixed on a very fine level. So like ketchup and pizza dough and mustard, they look like one thing. Okay, and they're mixed at a very small level. Like the pieces that are mixed together are very fine. A heterogeneous mixture is a mixture that looks like there's different things in it. Okay, so here's some examples of these things that you can see the heterogeneous mixture. And if you forget these, you know other things that are homo and hetero. So, like homosexual means people that like the same gender. So, that same, that's what homo means, is same. So, it looks the same. Hetero means that's heterosexual people like people of the different gender. So, it means different. Hetero means different. So if the mixture looks like there are different things in it, that's a heterogeneous mixture. Okay, that's it for today. I hope you took good notes. See you next time.